This video is about three-dimensional space. Now, you need to watch a video at the same time. You need to read a book, okay, for the details. Okay, why do we want to learn three-dimensional space? The reason is very simple, because we live in the three-dimensional space. Okay. First, we need to set up a system with three axes, x, y, and z. So whenever you set up a system, if I give you any triple, then let's uniquely identify a point in the space. For example, I give you a point, say 3, -7, and 5. Okay. So what point is that? 3 means you have 3 in the x-axis, and -7 is for the y. Okay. Say here is -7. Okay. So first of all, you can get a point like this. What's the coordinate for this point? Should it be 3, -7, and 0, right? Because the z, this is on xy plane, so the z coordinate is 0. Okay. Then this point go up in 5 units. Okay. So you get this point. It's like this. Here is a 5. Okay. So this point can be described by a triple, and the x-axis is 3, y is -7, and z is 5. Okay, three-dimensional space is quite different than the two-dimensional space. For example, say y equal to 2, say. This is the equation. Okay. All the points satisfy this equation in two-dimensional space or in three-dimensional space represent different graphs. In two-dimensional space, you have x and y. Okay. What kind of point satisfied this equation? For example, this point, say 2, 2. Okay. As long as the y coordinate is 2, they will satisfy this equation. So obviously, all the points on this horizontal line, they have their y coordinate equal to 2. Okay. So y equal to 2, the graph of that is this horizontal line. In the three-dimensional space, same equation. They will represent different things. Okay. You said, okay, here's a 2. So y equal to 2. You said it's still a line. Okay. So what is the equation for this line? I draw. This line I draw is on the xy plane. So the equation for that line really is what? Y is 2, right? Because every point you have a y coordinate equal to 2. And also what? All the z you can say is what? On the xy plane. So your z equal to 0. Okay. So this line really is like this 2 equation. Okay. Now if we have just one equation, then what? All the points satisfy this y equal to 2 equation is not a line in the three-dimensional space. It's a plane. Okay. It's a plane like this. Okay. You have to think about it. It's hard for me to draw. Okay. So y equal to 2 in the 2D space is a line, in the 3D space is a plane. Okay, now if I give you 2 points, x1, y1, and z1, and x2, y2, and z2. Okay. How do you find? I give you 2 points in the space. How do you find the distance between those? I call this point as a P1. This point is a P2. Okay. We use P1, P2, absolute value of that to represent the distance. Okay. This distance can be found by corresponding components subtract each other. Here's a 1, sorry. Z1 minus Z2. Okay, is x1 minus x2 or x2 minus x1 because they're square, so it doesn't matter which one go first. Okay. Why do we get this formula? You just think about it in the 2D. If you have x1, x2, x1, y1, x2, y2. That's in 2 point on the space, on the plane. Okay. So how do you find the distance? Say this is the x1, y1. This is the x2, y2. So this is the distance we're looking for. Okay. And this length obviously is what? x2 minus x1, right? And this distance is y2 minus y1. Then you use Pythagorean theory. You can find the d. A squared plus b squared equal to d squared. You take square roots. Then you find this formula. Similarly, we got this 3D formula. Okay. Now, there's a special equation like this. X minus h squared plus y minus k squared plus z minus l squared equal to r squared. Okay. All the points satisfy this equation. They form a very special set. Let's look at what is it. Okay. Now this is three-dimensional space. Okay. Now this point is h, k, and l. Okay. Now this point says x, y, z. Okay. If x, y, z, the distance to the given one is r. Okay. That's what this equation means, right? Because this is a distance formula, then you square that. All the points in the space x, y, z satisfy this equation. In the other words, all the points in the space x, y, z, the distance to the given one, h, k, l, is r. All those points, obviously, they form a what? They form a sphere. Okay. So this equation here, all the x, y, z satisfy this equation, they will be on the surface of the sphere. So this is a sphere as the center is h, k, l, and r as radius. If you have a sphere center as origin, then this formula reduced to the one like this. Okay, now let's look at example of that. Example, we want to show that x squared plus y squared plus z squared plus 4x plus 2y plus z plus 6 equal to 0. Okay. Now, let's see what kind of... Okay, all the points x, y, z satisfy this equation. What's the graph of that? Now let's take a look. Okay. So, we put all the x together. Okay. 4x. Okay. Then we plus y squared plus 2y. Then plus z squared plus z, then we plus 6. Okay. equal to 0. That's the original problem. Okay. Now we want to complete square. So to do that, here we need to put 4 here. Okay. You have to figure that out. Here we'll have to add 1 here. Okay, I need to save space here. So for the z here, we need to add 1/4. Okay. Okay. So we add 4 here, 1 here, 1/4 here. Then we need to subtract that. Or minus 4, minus 1, minus 1/4. Then we make this equation still hold true because we add 4, subtract 4, and so on and so forth. So when you add 4, the first term can be write x plus 2 squared. Okay. The second one can be write y plus 1 squared, right? The third one can be write z plus 1/2 squared. Okay. That's why I add 1/4 there, because what? Because you spend this one. You spend this. You got z squared plus 2ab give you z plus b squared give you 1/4. Okay. So that's why I add 1/4 there. Okay. And plus 6 minus let me change this problem a little bit. Okay. Instead of add 4, I subtract 4 here. Let's subtract 6. Subtract 6. Okay. So we have like minus 6, minus 4, minus 1. So we get minus what? Minus 11. And the minus, so we got a minus 11, then minus 1/4. Okay. Equal to 0. So let me simplify this a little bit. Z plus 1/2 squared equal to 11 plus 1/4. Okay. So what we can say about all the x, y, z satisfy this equation? Obviously, they form a surface. They form a sphere, and the center is, what is the center? The center is minus 2, minus 1, and minus 1/2. Okay. The radius r there is r squared equal to 11 plus 1/4. Okay. If you want to find r, you take square roots. Okay, now let's look at another example. They give you the 3 points. P, 3, minus 2, minus 3. Okay. Q, 7, 0, 1. R here is 1, 2, and 1. Okay. These 3 points form a triangle. Okay. We will ask to check this triangle either right triangle or isosceles triangle. Okay. So you have 3 points. Say P, Q, R. Okay. So they will form a triangle. To tell what kind of triangle is that, we need to find the length of this triangle. Okay. Now let's find. How do you find the length of a triangle? You need to find the distance between 2 points. For example, find the PQ. PQ. The length is the distance of 2 points. PQ. Okay. We use that formula to find the distance is square roots. Look at the P point and point Q. Okay, so it's 3 minus 7. Doesn't matter, 3 minus 7 or 7 minus 3. You're going to take a square. Okay. Plus minus 2 minus 0 square plus minus 3 minus 1 square. Okay. So this gives you 4 square 16 minus 2 minus 0 is minus 2 square give you 4. Then minus 3 minus 1 minus 4 square give you 16 again. Okay, so this whole sentence give you square root of 36, which is 6. Okay. Next, let's find the point Q and P or PQ, same thing. Okay. No. Q and R. Okay. Let's find this distance. Q, R. Okay. Find the length between point Q and point R is Q and R. So 7 minus 1 square, 7 minus 1 square, plus 0 minus 2 square, plus 1 minus 1 square. Okay. So 7 minus 1 give you 6 square, 36 plus 4 square root of 40. Okay, now finally let's find the distance between R and P. R and P, square root, use the P point, 3 minus R minus 1 square plus minus 2 square plus minus 3 minus 1 square. So give the first one give you 2 square, then 4 square, then 4 square. Okay. Which give you 36 again, give you 6. Okay. So obviously this triangle, here's a 6, here's a 6, here's square root of 40. Is a isosceles triangle. Is this a right triangle? Right triangle, you need to check what? You check, look at, okay, to check to be right triangle or not, look at two smallest length. For example, 6 are two smallest one. So you check 6 square plus 6 square, see that equal to the largest length, which is 40 square. The square root of 40 square. I mean this. If they're equal, then it's a right triangle. Otherwise, it's not. Okay. Okay. Again, if you give it problem, say P, Q, and R. You are asking to check those 3 points on the same line or not. How do you do that? Same thing. You need to find the distance between P and Q, find the distance between Q and R, then find the distance of P and R. If you can find the two, PQ plus QR, if that equal to another one, P and R. If they're equal, that means what? Those 3 points on the same line. Otherwise, it's not. Okay, now let's look at one more example. Okay, this example is like this. I give you point 3 minus 7, 5 again. I want to find the distance. Following distance. First, A, we want to find the distance, okay, for the given point to the XY plane. B, we want to find the given distance to the YZ plane. C, to the XY plane, YZ plane, and XZ plane. D, we want to find a given point, the distance to the x-axis. E, y-axis. F, z-axis. Okay. First of all, let's find this point in the space. X, Y, and Z. Okay. I told you this point is, here is a 3 on the X. Y is a -7. Okay, so is here -7. Then go up 5 units. Okay. So this point is 3, -7, and 5. Okay. Okay. Now, first of all, let's answer the question A. Okay. This point, the distance, this point to the xy plane. This is here, and here is the xy plane. Obviously, the distance is what? 5, right? Okay, that's the easy part. B, the distance to the yz plane. What is the yz plane? This is the yz plane. Okay, so what is the distance to the yz plane? Wait, not that point, sorry. The point here is 3, -7, and 5. Not that one. Okay. Okay. So the distance to the yz plane is this one, right? What is that? 3. Correct? Okay, C. The distance to the, what is that? What is C? Distance to the xz plane. Xz plane is this plane determined by x and z axis. The distance obviously is this one, okay? Which is what? 7, right? We're talking about distance, so you don't say -7, it's 7, okay? Okay, D. To the x-axis, okay? So, this is the point. Here is the x-axis, so the distance to the x-axis is this length. Okay. So this is the right triangle. Okay, that's what we're looking for. Okay, length of this hypotenuse. So the distance to the x-axis is square root. Use Pythagorean theory. This is 7. This is 5. So 5 square plus 7 square. Square root of that give you the distance to the x-axis. Okay. E. To the y-axis. Okay, this point, the distance to the y-axis is this one. Okay, you see that? Okay. And here is a right triangle. Okay. So use Pythagorean theory again. This distance is 3, and this one is 5. So square root of that is 5 square plus 3 square. Take square roots. Then you answer that. Okay. The last one, F. F is this point, the distance to the z-axis, which is the same as, see, this distance to the z-axis is the same distance as this one. Therefore, use the Pythagorean theory again. this length is 7 and this one is 3. So square root of 7 squared plus 3 squared. Then we finished.